Hello, everyone, and thank you for joining our live session today. My name is Larissa. I'm an event planner at Reactor, joining you from São Paulo in Brazil. Before we start, I have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. The session is being recorded and will be available to view on demand here on the Reactor YouTube channel within 48 hours. Keep an eye on the chat. We'll be dropping helpful links and checking for questions for our presenter to answer by the end of the session. I will now turn over to our speaker for today. Thank you.
Hello. I hope everyone can hear me. Welcome to our session here. I just want to find the right browser. I've kind of lost my browser here, so if you just give me 1 second. So good morning or good afternoon, wherever you are. I've put together a couple of slides for us. We're busy with session number 4 of 11 for the Azure Developer Certification. So welcome to our session this morning or afternoon, whatever the time is on your side. My name is Johan Meiberg. I'm a technical trainer with Microsoft here in the UK. I've put a couple of links at the bottom of this page. You will see that if you go to my GitHub profile, so Yeti Mac, then you will see there's a repo called Course Content. There's lots of different examples and other tools in there that you might find useful for some of our other courses as well. And then, of course, if you want to get some hands-on, I'm going to cover a little bit in terms of theory with you about Cosmos DB today. If you want to get some hands-on and some practical experience with this, which in most cases is actually quite crucial for our certifications, then you can also go take a look at AZ204 Labs, akka.ms/AZ204 Labs. That's essentially the labs we've got, and you can essentially work through the Cosmos DB lab there. I wouldn't say it's the greatest of labs because it essentially attempts to help you migrate data from SQL Server into Cosmos DB. But if you haven't played around programmatically with Cosmos DB, it's certainly a nice lab to work through. Our agenda for today, just briefly, we're going to introduce Cosmos DB. What is Cosmos DB for that matter? Of course, Cosmos DB is a bit of a different ballgame. It's not your standard type of database. So we'll talk about what is Cosmos DB and some of the concepts behind that. We will explore some of the APIs that essentially is available through Cosmos DB. Each of these APIs have got different data types essentially. And then we will look at the SDK. Frankly, the SDK, very similar to the last session we did around storage. What you need to be mindful of is the structure. So I'll again have a slide that outlines that structure. If you can get your head around the structure, most of our services have got some sort of a structure or taxonomy that you need to adhere to. All right, let's introduce Cosmos DB. And I think what's important here is Cosmos DB is not like our traditional sort of database management systems. And I'm going to just drag something onto the screen here. You're going to have to look at my ugly drawing again. But if you think of traditional systems, like, for example, something like that is not where my mouse should be. So if you look at something like SQL Server, for example, give me just 1 second here, because it does look like my pen is not on the right spot here. Yeah, that's not going to work. If you look at something like SQL traditionally, of course, what we would have had is we would have had some sort of a database system, a server or something that's got access to some storage, usually quite a bit of usually, huge amounts of RAM and CPU, because something like SQL can be quite resource hungry. And then we might configure this in a type of a always on type configuration where we've got a secondary system, and if the first system is affected, then we basically fail over to the second SQL server, which is essentially my secondary in a type of cluster setup, right? Something like SQL always on or something like that. But this tended to be more of a centralized database management system. So typically, you've got one single host that is doing all of that number crunching and all of that processing and interacting with your data wherever that data is stored. So if you contrast that with something like Cosmos DB, you will see that we're going to have several hosts, right? We're going to have a variety of different hosts, and each of these hosts is going to have its own resources. So if you think, for example, along the line of something like storage, this host is going to have his own storage. Each going to have their own CPU and RAM, and whatever other resources are available for these individual hosts. And what this essentially implies is, as opposed to now creating a relational database design with tables and references and primary foreign keys between those tables, you're going to provision a system that runs across multiple hosts. So inherently, with Cosmos DB, your database is fragmented, right, across multiple hosts that are actually able to interact with some of that data. Now, this generally at a high level, and they've removed this component out of the course completely, predominantly because we've got a full NoSQL course at this point in time for Cosmos DB. So the amount of learning inside this certification for Cosmos DB is very, very limited. In our courses, it's a very, very short course. So in this context, what we've got is we've essentially got something called this is known as a physical partition. You cannot actually control that except by controlling something known as a logical partition. And with a logical partition, we're basically identifying items based on based on a partition key. And what you essentially want to happen here is you want your partitions, again, depending predominantly on what you're trying to achieve. If you're optimizing for things like reads and writes and things like that, but you might end up with one host with either one or more logical partitions. The way these logical partitions are structured and actually work is when you are writing and creating an item into Cosmos DB, we will not allow you to create some of these structures without specifying the partition key. So you're going to use a partition key that makes sense and gets you some of the scale you want. I'll give you maybe 2 or 3 good and maybe 2 or 3 bad examples. The idea here is that we don't end up with one partition that contains all of our data. This is known as a hot partition, right? So you want to ensure that the partition key you are using is going to segregate your data so that these hosts can process this information and that most of your queries don't go to a single host. When I'm running a query against Cosmos DB, I can actually tell it, you can go and query 10 of these hosts at any point in time, and it'll go off and it'll query 10 of those hosts at any point in time. So again, what you're trying to do is you're trying to avoid creating what's known as a hot partition, where all the transactions are essentially going to a single partition, and that means you've got a single host that is doing doing that number crunching and executing those transactions for you. You want to tap into the fact that, hey, if I run this query, there's going to be 5 or 6 hosts that are coming back with my information, and you can immediately see from this conversation that you want to build this conceptually into your design. You want to understand, are we going to do lots of writes? Are we going to be doing lots of reads? Is it going to be a combination of reading or writing? And you will essentially design this structure in that way. The actual logical partitions are these logical partitions and physical partitions I'm referring to here is not a big part of the course really, so you don't have to really worry about this as far as the exam is concerned. However, I find it really difficult to talk about Cosmos DB if we're not talking about this underlying architecture of Cosmos DB. And ideally what you want is, irrespective of how many partitions there are, you want these hosts to then have a fairly sort of distributed and sort of, you know, equal amount of transactions and operations that are going to each of these individual hosts. And the way to do that is to, for example, not use a partition key that's going to force everything into a single partition. I'll give you a brief example of this. If I was building an application in the UK, and the application was basically for people that live inside of England, a fair chunk of those people are going to be living inside of the London area. And if I use the city name as the partition key, I'm going to end up with, you know, with the London partition becoming one of my biggest partitions, because most of my users probably live in London, right? So if I go for something in the UK for first name, that might actually be a little bit more distributed, because, you know, we don't just have the traditional English names like Paul and you know, and those sort of English names. There's also a wide variety of other folks from other countries, for example, like myself, who will actually be using the word Johan when I'm actually adding my first name. So try to use the right key for these partitions, and then you will be able to tap into that distributed nature and get multiple hosts to actually work together to provide you with your data and information. So this is definitely something you want to be mindful of. There are limits to how big some of these can grow, but this is something that we treat generally in a little bit more detail in some of our Cosmos DB for SQL course. I'll see if I can get you the course code for that. I think it's DP something. I'll see if I can get that when I'm busy answering questions. All right, so we're not just talking here about a single host. We are talking about multiple hosts. And on top of that, all of these hosts might actually be in the UK. And hopefully you can also see where I'm going with this. I might actually have some other hosts, and I might decide to replicate this over to South Africa, or replicate this over to the US. And then we will start replicating your data over to those other regions. So in essence, one of the key differences between Cosmos DB and other database management systems is we're not traditionally following that centralized service it can be a central point of failure. We're talking about a distributed, globally replicated architecture here. So if we pop back in here, you can see that's essentially what I refer to here: distributed, replicated database service supporting a variety of APIs. We'll talk about those different APIs in a few minutes. I've got some demos for you as well that will definitely show you the different data types behind this. But one of the things they probably will ask you in the exam here is, hey, what you are trying to ensure is that your data is always replicated and you're never working with stale data. Which level of consistency should you select? So when I configure something like Cosmos DB, and let me just pop into my Cosmos DB here, I think one of these, like this one over here, might give you some options. There you can see the default consistency in my case here is session, right? But I can also set it to strong, bounded staleness. What are all these other options? And what I've tried to do here is I've tried to put these options just in a very short summary about what these options are. If we have to move from a strong consistency all the way to an eventual consistency, you can see that the strong consistency is always going to require the latest data. So we're not committing on the master, if you like, if you want to use that terminology. We're not committing on the master until we've replicated the data everywhere. So everything is completely accurate. And then moving away from strong replication all the way to eventual, you'll see that these different consistency levels moves away from a strong consistency. And as we move down the stack to eventual consistency, this essentially implies that if the consistency is eventual and I commit, I would be committing on the master immediately, irrespective of where I've replicated this data to. So in the exam, they will ask you questions. What's the difference between bounded staleness and session, for example? And you can see with bounded staleness, we can specify whatever that delay is. So I can specify either by amount of time or by the number of updates / versions of my item, what that delay is going to be. If I use something like session, you will see within a SDK session, if I'm programmatically interacting with Cosmos DB, in that session of mine, nothing will be stale. All right. So that's almost like a per user type thing, if you want to see it like that. And then the last one, consistent prefix, where we're basically ensuring that at the very least, these items will be appearing in the right order. Whereas if we look at something like the eventual consistency, and this obviously is the most loose consistency of the lot, then you will see for eventual consistency, we are basically committing on the master irrespective of what happens. And to this end, if you're using eventual consistency, you can also not even guarantee that the items will appear in the right order, right? So eventual is a very, very loose consistency, and you can tweak and change this after you've created the Cosmos DB account. Now, something else that you will also notice is Cosmos DB has got the concept of request units. So what we've done is we've taken the storage, the CPU, some other resources, the number of transactions, and we've boiled your interaction with Cosmos DB down into what's known as a RU, or a request unit. These request units are critical because depending on how you provision your Cosmos DB service, you might have a limited amount of request units available. So actually how this works, and I'm going to try to draw this out. A colleague of mine made a very nice video, which is not available anymore. So I'm going to try to draw it out. You will see that we've got a few options. And I'm not gonna hammer on about the specific all the options here, but you'll notice you've got the option to specify a max RUs, and then based on the transactions, of course, you have to essentially stay under that maximum option that you've got. Now, what we can also do is we can also have, that's known as provision throughput. But what we can also have is we can also say, well, you don't specify a maximum. And what we will do is we will kind of give you, X amount of maximum. And there might also be a maximum that you specify for this. But we will essentially ensure that there's always some processing available for you to process your requests. But as you can see in here, with the first example, all of this space is basically wasted. All of that space there. With the second example, all of this space over here is really wasted, which means that there's more processing than what you actually require. And the last option to this end is something known as serverless. And serverless is a pure consumption-based scenario. So we adapt exactly to what you might need. There's also even a burst type option for some of these options, right? So request units or RUs is essentially us saying to you, hey, when you provision some of these services, you need to go and figure out how many requests you are planning to make to this service. And then you can choose when you provision your Cosmos DB account, you can choose which of these options you want. I'd like to show that to you just quickly. I'm going to go to Cosmos DB. You'll notice I'm going to click on the Create button. We will talk about these APIs in a few minutes. Don't worry about this, but you can see that there is NoSQL, for example. There's one for MongoDB. If I click on others, you can see there's Apache Gremlin, basically the Apache Tinkerpop project. And you can see there's Apache Cassandra and a variety of other options. For these other options, we'll talk in a lot more detail on the next slide around what these different options are. Suffice to say, it's different data types that we're really trying to store. Some of them might be column type data. Some of them might be, some of them might just be NoSQL type scenarios. It just depends what you're trying to achieve. So if I say, for argument's sake, let's choose, let's go for MongoDB here. You can see there's a vCore cluster option, or there's a request unit database amount. If I click on the create button here, you'll notice towards the bottom there, it's actually prompting me for provision throughput. And you can see with provision throughput, we've got the manual option. That's where I specify for this service, I'm going to always have 50 requests per second, or 5,000 RUs per, available, or 10,000 RUs, or whatever that requirement is. But I can also flip this over to something called auto scale, and that's where I mentioned in the diagram where we're essentially auto scaling based on what's actually happening. And then the last option, serverless, this is where we're basically giving you almost exactly what you need. So if there's completely unpredictable traffic, because as we all know, traffic is not always consistent. If there's completely unpredictable traffic, the provision throughput option might not work for you, and you might want to go for something like serverless. Right, I'm not going to create this database. It can take a few minutes, but you'll notice if I go for global distribution there, I can hit the enable button. Once I do that, I can essentially replicate this data over to a variety of different other locations and regions. There is, of course, also a networking component that allows me to lock down where I can access this Cosmos DB from. And then you'll notice that there's a backup policy, some security options for encryption. And once I provision that, it's essentially going to look more or less like one of these. There's my always on NoSQL service. And you can see that I've got a data explorer there, but more importantly, there's a URI that I can use, and our SDK is going to require some of these items. So if I scroll down here, you should notice if I click on replicate data globally, right? At this point, if I select South Africa and I just hit the save button, right? Click on save. What we will do is we will start replicating your entire Cosmos DB data set into South Africa. Now, this is something that I'm always a little bit wary of leaving over and leaving open. So it's also not really part of the course, but what you want to avoid is someone landing on this interface and thinking, this application is not available in all these regions. That's why it's so slow. And they go and check off all these regions. If I've got a 500 terabyte database, what we're essentially setting up here is for that 5,000 terabyte or whatever that amount is to be replicated globally. So your cost might go through the roof if I hit the save button here and I've asked it to replicate this information. So that's the first option, the global replication. We spoke a little bit about that. And then if I look at my different consistency levels, I'm not going to save that. If I look at my different consistency levels, there you can see the default is the session level consistency, which implies that in my user session, everything will be consistent. And I can go and change this as well, and you will see with eventual, these items even roll in different orders than what they were actually committed. So from eventual, which is the loosest consistency, to strong, that is basically the strongest consistency and the strictest sort of rules around that. All right, so we spoke about what is Cosmos DB for that matter. We touched briefly on the different consistency levels. I did allude to what these request units are, but I do want you to ensure that if you're prepping for the exam, that you delve a little bit deeper into these things. There's maybe 2 or 3 additional topics that will come out of the course material that I don't have time to cover in the session. So one of them is essentially a change feed. So Cosmos DB also has a change feed, and the change feed allows me to monitor what's going on. Now, very similar to our storage account, where there's also a change feed. We've got a similar process here. You might also say, but why do I need a change feed if I've got something like, Azure Event Grid that can essentially trigger a function when there's a new item added in the Cosmos DB? It's just features and capability that we're rolling out inside the product. Right? And don't be surprised if that just keeps going. Now, talking about the different APIs, I do want to spend a little bit of time. And as you saw earlier, when I went and created a Cosmos DB service here, it prompted me for the API that I want to use. Now, you need to go and figure out, hang on, what type of data are we going to be storing? Do we have existing data? For example, if you're already using something like MongoDB, use MongoDB, right? In actual fact, we provide compatibility for most existing MongoDB tools, but we also provide compatibility for something like Apache Cassandra, for example. So your existing applications can actually just continue to work if you've migrated and ported some of that data over into Cosmos DB. Now, let's quickly touch on these APIs, and I'm going to give you a short example of some of these. What I'll do is I'll show you the NoSQL option, show you the document-based items, and then I'll also show you the Apache Tinkerpop or the Gremlin-based scenario, which you can see there is more based on relationships between entities. So I'm going to quickly touch on these, and then I'll demonstrate some of them. NoSQL, basically document-based. We're talking predominantly about JSON documents that are essentially stored in that in the system. And of course, I can go and query this information using SQL query. We can also do something called a point query if we wanted to, a point read for that matter. Cosmos DB for NoSQL generally gets the latest features first, because this is the most, I think this is the service we've had for the most amount of time, actually, as part of this, possibly something like MongoDB as well. But when we release features, we'll probably plug them into Cosmos for NoSQL first. So to this end, you will see if you wanted to store something like a vector database, right? If I go into my Cosmos DB here for NoSQL, and I scroll down to the bottom here, you will see if I go to features, sorry, I missed that. There you can see a variety of different features. And one of these features is, you can see there, vector search for NoSQL API. So you might be using one of these large language models and you want to store and query some of those vectors. What is the closest relative to this item? Things like that. So NoSQL, probably the most prominent one. And then we've also, of course, got MongoDB. MongoDB is a very well-known database management system. Basically, we support that BSON format, and we're all MongoDB compatible. So most of your existing applications should continue to work with that. But we also support PostgreSQL, essentially distributed tables via those citus databases. And then we also, as you can see there, we also support Cassandra, which is also a column-based, more like almost very similar to NoSQL, but more also a table type scenario, right? Very similar to our table services. This one here, Gremlin or Apache Tinkerpop for that matter, is an interesting one for me. This one demos really nicely, so I hope my demo will actually show what I mean with this. But if you think, for example, of scenarios where I want to build something like LinkedIn, and with LinkedIn, I want to say, hey, who are my closest relations that is connected to person A, right? Who does person A know that is one person away from me, right? So with Gremlin, we are talking about more relationship type scenarios, right? Think, for example, of you're building something like an Xbox system, and you want to understand, hey, who's my immediate friends? Who's my friend's friends? Those sort of queries. And then, of course, the last one here, table service. Now, what makes the table service very, very interesting is the fact that our table service is compatible with our storage table service. I'm not sure who was on the call last week when you both spoke about Azure storage accounts in this in that session, but we touched on a NoSQL table type scenario. And I can literally just change my storage account connection string to a Cosmos DB connection string, and we can have virtually the same SDK that interacts with those tables. So actually, Azure only has one table SDK, and that table SDK works for Cosmos DB. It also works for storage. However, you can see what I've added here is it's better than tables. You're getting better performance with tables, and inherently you're also getting a little bit more control with Cosmos DB tables than what you might be getting with something like storage account tables. All right, so let me demonstrate a few of these just so you get your head around what they look like. So what I'm going to do here is I'm going to first go for my NoSQL service, right? I'm going to head up to my Data Explorer here. It's going to connect. And there you can see there's a sample container. And if I click on items, there's going to be some items. There's items. In fact, I can just create a new query and execute that query. Looks like it's got a problem with my networking here. Huh. Interesting that it doesn't show that. Not too concerned though, because I will see if I can show it in a bit of a different way. Yeah, it's actually, it looks like it's actually from here. Let me just quickly. Okay, cores is not the issue. Okay, that is all networks. Quite happy with that. Huh. Interesting that it doesn't do that. Well, I don't think I can demonstrate that now, but don't worry about that too much. There you can see there's always gremlin, right? In fact, folks, we've got time actually. So what I'm going to do is I'm going to create a Cosmos DB for table service here quickly. Let's select that we're doing learning, and I'm going to go for my dev subscription. I'm going to go for always on, and I'm going to give it a name, Jazz 204. That should be unique, and you'll see in this context what I can specify: enable availability zones. I'm going to go for central. I'm going to go for, let's see, I can go for UK South. It looks okay. You can see that I can specify things like provision throughput here. There's a free tier that applies. I'm not going to apply the free tier here. And you can also see they limit the total amount of throughput that can be provisioned on this account. I'm not going to set that up. It bites back in the rest of my demo. And then you can see there from a global distribution perspective, I can enable that. From a networking perspective, I want it to be accessed from everywhere basically. And this will probably take around 20 odd sort of seconds for me to provision, 20-30 seconds. In the meantime, let me show you what Cosmos DB looks like for something like our Gremlin service. All right, so I'll come back to that in a few minutes. There's my Gremlin service. You can see I've got the Data Explorer there. And if I just minimize that, you can see that there's the actual graph. And if I load the graph, you can see that there's my information. Now, what I'm going to do is I'm going to just show the name here so you can actually see the name. And you can see in here what I've done is I've created some vertices and a couple of additional options there. And you can see there that Bob knows David. David doesn't know Bob, but Johan knows Bob. And Alice knows Bob. Charlie, Bob knows Charlie, but Charlie doesn't know Bob. If I click on Charlie, you will see slightly different scenario. So we're really referring here to different types of data structures based on the API that you might have selected. And that's what makes Cosmos DB extremely flexible. And obviously, if you're looking at some of the scalability that we pack into this service, you're getting huge amount of flexibility from an API perspective, but you're still getting that massive scale that you might expect from enterprise level database system. So this will take probably another few seconds. I will wait for this. I will wait for this to get provisioned, and then I'll see if I can at least show that to you. But my other Cosmos DB here, this NoSQL one, is obviously some sort of a problem with this one. I'm not going to try to troubleshoot that now. Let's wait for this one to complete. Shouldn't take too much longer. All right, so just backing up here again, Cosmos DB has got a variety of different APIs available, and when you create your Cosmos DB account, remember the account, we'll talk about that in a few more minutes. When you create your Cosmos DB account, it's based on one of those APIs. All right, let's see if it's actually finished. It's not. There we go, it is finished. It's deployed that. And you can see there, if I go to my Data Explorer here, that I can go and create a new table. This is something like sales orders for that matter. And you can see I can go and configure things like auto scale or the manual scale that I spoke about earlier. If we're going to have consistent number of requests coming through, manual scale should be sufficient, because if my amount of transactions are mostly all going to come in roughly at the same sort of, in the same cadence, if you like. But if I was not sure about that, I can configure something like auto scale, and we will make sure the amount of request units are available when you need them, up to a maximum number of RUs. So I'm going to click on OK here, and this will actually create a table. It's probably not a bad idea to create the table API, because when we talk about the structure in a few minutes, I do want you to notice that the table API is the only one that does not adhere to the structure, funny enough. Right, so this will create a database table, and you can see that there's all my different entities, and I can go and add an entity, and you can see that there's the primary partition key, web1, and this is the about option, and I can go and add some properties there. This is our story, for example. We started in a garage, and you can also see that this is a little story about the founders that we founded this organization, all information for our public website, and you can see I can go and add that entity, and I've got the entity in there now, but I can go and add another entity. I don't have to go with that same structure or that same schema. So our Cosmos DB, as well as our SQL table storage, supports what's known as a jagged schema, because at this point what I can do is I can say this is also web1, but this is the contact page typically, or something like that. So there's our telephone number 555 and what fax number. When was the last time you heard that? Also 555 something. So there you can see there's my two entities in there now, and I can go and query some of these entities to my heart's content. All right, so different types of data structures based on the API that you've selected for your Cosmos DB account. Now, the real question you might have is, okay, Johan, I'm happy, I'm quite content to provision the service and start playing around with the service. Now, if you are a developer, which I'm assuming most of you are, you're probably going to want to know, well, how do I interact with the service? All our services have REST capabilities, but of course, we've got an SDK for .NET and for Java and a couple of other services like JavaScript, for example, where we've got a full object model that represents Cosmos DB, very similar to the object model that we had with storage accounts last week. Remember, on the Azure storage account, that structure was quite important. You've got the account, then a container, and then the individual blob. We've got a very similar structure in Cosmos DB. There's just one additional component that makes up the building blocks for this. So the building blocks or the structure in Cosmos DB, and remember last week I had a little asterisk there to specify that you can always look for a structure in services, right? It gives you some sort of insight as to where the service might scale and even leading to some best practices there. But for Cosmos DB, if I wanted to programmatically interact with Cosmos DB, what I'll do is I will create an account, and in this account, in instantiating the account, I will essentially authenticate against the service. Once I'm authenticated against the service, I'll be able to enumerate the databases. Once I've enumerated the databases, there is a database client, and the database client allows me to interface and interact with the database properties at that level in the structure. And then you can see I can then in turn enumerate the containers. And the containers are effectively where the items are stored. So we store our items in a container, and a container lives in a database, which lives in that storage account. They might ask you questions about the structure in the exam. I'm always harping on about structure. Please believe me, it's a very good way to learn about software, is to figure out the structure. I'm always on about this. If you even look at something like Excel, Excel has also got a structure. There's a workbook. Inside the workbook, there's a sheet. Inside the sheet, there's the actual rows and columns, right? Cosmos DB and some of the other services have some of that structure as well. So there you can see I create the account, I create a database, I create a container, and then I create the items. Now, the only one that's a little bit different here is the table API, because the table API doesn't have a concept of a database. It doesn't have the concept of a container. It's just got the account, and inside the account, there's one or more tables. So the table API is slightly different than the other APIs we've got in there. All right, so let's see if I can, let's see if we can actually, I'm not 100% sure why this one here. There's the table API. You can see that there's my account level throughput and options. There's some features, and you'll see because this is the table API, it doesn't support all those features. There's again my default consistency that I can go and configure and select. And of course, this level of consistency might depend a lot on where you're expecting to write data to the service, where you're expected to read data from the service. One of the points I want to make clear here is when you are building and designing a Cosmos database system, most of your relational database design rules are going to go out the window. These are different types of data structures. So hence, we punt Cosmos DB as our service, database service for NoSQL type data. Right, and under that banner, we support a wide variety of different APIs. So one last thing that I would like to go and do quickly, if I go for NoSQL here, and I just go to the overview or to the data explorer rather. There's a quick start. So just a couple of examples. There you can see connect your app to Cosmos DB. There you can see Cosmos client new, and you can see there's my connection string. I'm passing up there, and I can maybe look at some sample code here. I've got a better idea. AZ204 labs. So you can see there's the lab for this learning path, constructed polyglot data solution, basically extracting data out of SQL Server and pushing that data into out of a storage account and downloading from a SQL database. But if I scroll to the bottom here, this is part of the lab, then you will see that they're basically gonna prompt us to add this package, .NET add package, Azure Cosmos, Microsoft.Azure Cosmos, a specific version of that. And if I scroll down here, then you can see I'm essentially creating a new Cosmos client, takes a connection string as a parameter, and then I'm enumerating the databases, and then I'm enumerating the containers, right? Or not enumerating, I'm reading the container, and once I've got the container, I can effectively start running queries. Like there you can see, select value products from models. I'm doing a join on models.products, where product ID is whatever the ID is. And that's essentially where, where I can start. You can see the container.get item query iterator. It's basically almost like a type of, like a read request. And then while iterator has more results, in other words, there's a couple of options in the type of collection, and then I can essentially, read some of the values out of that item, for example. Okay, so they might actually go and test some of these scenarios in the exam. Make sure you've at least looked at some of, the code that we've made available here. And then just in conclusion, keep in mind that I did mention at the beginning, Cosmos DB is not as big a part of this course as it used to be in the past. We've removed a variety of different options. There is a dedicated course now for Cosmos DB on NoSQL. I think it's like a 4-day course that you can do through a training provider, or go and just read up on some of that information. I'll see if I can pop that onto the chat while I'm busy fielding some questions. So just in conclusion and summarizing, why Cosmos DB? Cosmos DB is a very performant, distributed, enterprise sort of scale related database service. We were talking about 99.999% read-write type operations and availability, and we support a variety of APIs. I did mention that some of the concepts that you need to come to grips with is the structure, and they might ask you questions about the structure in the exam. You can see that I've got the account, the database, the container, and then the items beneath that. And then lastly, also the replication. I'm quite convinced in the exam you're going to get a question about that replication. So understand what the different replication options are. And other than that, let me know if you have any questions. I think I've covered everything I wanted to cover. So let's see if there are any questions.
Okay, so the first question we had was from Jimmy. Does the change feed behave analog to the chosen consistency level?
Let me just quickly read that question, if it's okay.
Of course, I popped it on the screen for you.
Okay. Does the change feed behave analog to the chosen consistency level? That's a good question, Demi. I'm not 100% sure, to be honest with you. I'm not 100% sure. I think it will be completely separate, actually, because it's not a replication capability. But you can hear I'm speculating, so I'm honestly not 100% sure.
Okay, we have a question from Pablo as well. I'll pop it on the screen. For what example applications are people using Cosmos DB?
So a good example of Cosmos DB is when you do need some storage, when you do need some scale, and you're not necessarily looking at traditional, relational data type structures. So if you're looking at a NoSQL solution, and keep in mind that NoSQL doesn't mean NoSQL, it means not only SQL. So if I can maybe even try to add to this, let me just pull up my whiteboard here. Give me a second. So if you think about it in this context, you might have your traditional sort of relational type data structures where I've got columns, primary foreign key type scenarios where that column comes from that column. This is a very specific scenario, and for the most part 80-90% of your data is going to fall into this type of structure and this data schema, if you like. But what we used to do traditionally in the past is we used to say, well, here's some data we need for our applications. It's not really relational data, so all we're going to do is we're going to create a table in SQL Server, and we're just going to query this table, right? It's not relational data, but we can do that in SQL Server. Now, what we are saying is, hey, maybe 20% of your data is not relational data. Now, as opposed to storing that data in tables, which is more geared for traditional relational data structures, what we are saying is these 20% of items, don't store them in SQL databases, store them in NoSQL databases. And again, based on the data structure and data type you might be working with, this might be something like, this might be MongoDB, this might be Tinkerpop, right? Or Apache Gremlin in that context. Different types of data types. I hope that answers your question. So okay. We're talking here about distributed data with multiple hosts hosting your data and not relational data. So that should immediately, if you realize, well, there's no relational data we need to work with here, you're probably going to look for something like a NoSQL type system. You can look no further than Cosmos DB. Cosmos DB supports a variety of different NoSQL data structures. I hope that answered the question.
Johan, we have 2 questions from Mr. Programmer. They are complementary.
Hello, Mr. Programmer.
The first
Programmer
question
is a consistent question asker. I like that.
Yeah, I love it. The first question is about topic-based knowledge checks available for the certification. If you have any recommendations, I already sent in the chat the link where they can get those resources you shared with us. But if you want to complement with anything else, please go ahead.
Yeah, so as I usually keep saying, if you go to our exam page and you look at the assessments there's a self-assessment there. Those assessments have got a variety of different pools of questions. So work through our online assessment that's on our exam page. That is where you will get some questions around Cosmos DB, and that'll give you an idea what type of questions they're going to be asking. But I don't have anything on hand here. I will have to go dig that out. Mr. Programmer, you're welcome to hook up with me on LinkedIn and ask me the question there directly, and I'll see if I can go and find some links for you and respond like that. But for the most part, if you just do a search, any type of search for AZ-204, there you can see there is the training course, and you can see there somewhere here, it's going to have no, that's not what I want. There we go. There's the certified developer, and you can see that there's a practice exam. And if you click on the practice test here, it's going to boot up 50 questions across all of the learning paths for this material. And Cosmos DB is going to be inside of that. Unfortunately, right now, we cannot take the practice assessment and say, just ask me questions about that. On top of that, if I just go do a search, I like to use the term getting started with Cosmos DB, getting started with whatever service. You can see that there's a quick start in the Azure portal. There's going to be a couple of introductions there. But what I like to do usually is you will see that there's Cosmos DB. Let's just go Cosmos DB there quickly. I want to back up quickly there. There's Cosmos DB. You can see that there's some concepts, right? And I always try to also start with the concepts, right? Search for getting started, search for concepts, right? And you can see there's for MongoDB. What are some of the concepts around MongoDB? But to the same end, right? If I go for Apache Cassandra, for example, you might also see it doesn't have concepts there, but there's Gremlin, and you can see there's some of the concepts. So when I learn about a new service in Azure, I usually go for the concepts in the documentation. All right, I hope that answered that question.
Okay.
Another question, I think, yeah.
Yeah, his next question is related. So he asked if earning the certification, like the AZ-204, contribute towards becoming an MVP.
No, that's you don't have to be certified to become an MVP. If you want to become an MVP, start blogging, start posting social media, start becoming a community lead in your area, start hosting events like that. That's how you become an MVP. The exam and certification has got nothing to do with being an MVP.
Okay, that was all the questions we had from the audience.
No worries. Okay, folks, we're on time here, so I'm glad that I managed to wrap things up under the hour. I hope you learned a couple of things, and looking forward to seeing you next week when we'll start on the latest topic. Thank you very much, and have a great afternoon or evening. Thank you. Cheers.
Thank you. We'll see you next week. Thank you, everyone, for joining our session today. Before we finish, thank you for Johan for the content shared today in our session. And we are always looking to improve our sessions and our experience. So if you have any feedback for us, we would love to hear what you have to say. You can find the link in the chat or on the screen, and we'll see you on the next one.